Hey there. I wanted to go over the computations answers, and I'm going to try and like speed run it a little bit. So, not getting the seltzer water out, I'm going to get started right away. All right. So, there were 8 calculations. Let's go through the first one, subtraction of fractions. Houston, we have a problem. We have different sized pieces. So, the most efficient way would us to know, let's get them to have common denominators. The least common multiple is 12. So I would change this because I know 1/4 is equal to some 12ths. Oop, times 3 times 3. Good. So I have 7/12 minus 3/12 equals what? Now that they're the same size pieces, we can do 7 minus 3 is 4/12. But remember, with fractions, we don't want to just stop right there. We want to think, can I simplify this fraction? So we can. They share a common factor. The greatest common factor they share is 4. So I divide both the numerator and denominator by 4, and I get it to be 1/3. That was the answer to the first problem. Moving on. Okay, so let's do this. Now, we could just multiply straight across. We don't need common denominators for multiplying fractions. But also, there, if you multiply straight across, you'll get like 21 over 126. But we're multiplying times 7 and multiplying times 3. Basically, we are going to multiply the top 3 times 7 and then multiply 14 times 9. We could use the commutative property to flip them around to get 7 times 3 over 14 times 9. And then you could kind of start to see here, 7/14, If I multiply something times 7 and then divide it by 14, that's basically like times 7 and divided by 7 and 2. So we can cancel out the common factors. Say, well, instead of doing this, it would be like here. So we go diagonally, put the 2 7s on the bottom, the 1 7 on the top. Let's divide this by 3. How many 3s are in 3? 1. How many 3s are in 9? 3. So that would leave 1 times 1 over 1 times 3. Another way we could see this, decompose the numbers a little bit, like 1 times 3 times 1 times 7, because we have 3 times 7 on the top. And the bottom is 2 times 7, which is 14, times 3 times 3. So basically, we've never done this before, so it might look weird. We're saying, we're going to multiply times 3, but then we're also going to divide by 3. Let's cancel that out. And now we have 1 times 1 times 7. And then I'm going to divide that by 2 times 7 times 3. Well, I could cross off the 7 on the top that I'm also going to divide by. So then what's left? 1 times 1 over 2 times 3. That's what we're doing by crossing them off. We're basically saying, why multiply by a number and then divide by it? We're like double doing the work. So instead of simplifying 21 and 126 at the end, we could simplify at the beginning by canceling out common factors when we multiply. Okay. Now, Mr. Dick says we should estimate first. Let's just estimate, y'all. Let's round up. This is about 3 times 7. We round it up in both, so I know our answer is going to be less than 21, but it's going to be more than 2 times 6. So if you thought the answer was 12, it's probably because you just did 2 partial products. No. So what I want you to do with mixed numbers is change them to be improper when we multiply. And there's going to be some satisfaction coming. All right. 2 wholes of thirds. Well, 1 whole is 3/3, right? 3/3 plus 3/3 plus 2/3. That's what we basically do is 2 times 3, 2 wholes of 3 are 6, plus 2 is 8/3. Let's try it this way. Times 6 times 4 is 24 fourths, plus 3 more is 27 fourths. Now, I set us up here to have some satisfaction. What can you see? Ooh, look across. 8 times 4, they're both multiples of 4. If I divide this by 4, I have 1. If I divide this by 4, I have 2. What about 27 and 3? Yeah, I can simplify these both by 3. How many 3's are in 3? 1. How many 3's are in 27? 9. So now I just have 2 times 9 over 1 times 1, and that equals 18. What was our estimate? 21. So it was close. All right. Now in the longer version, I want you to think of division as how many are in In this case, how many fourths are in 8 wholes? That's a lot of fourths. If I have 8 pies, I cut them into 4 pieces each, or 8 cookies. I cut them into 4. 1 whole is 4, 2 wholes is 8, 3 wholes is 12, and you keep going. But for time's sake, I'm just going to remind you to keep a rule when we divide fractions. We can keep, change, and flip to the reciprocal. Keep the same number, the first number the same, and instead of dividing by a fraction, we can multiply by the reciprocal. So let's change this to be multiply and flip this. Instead of 1 over 4, make it 4 over 1. And if you really want to do this, that's fine. The answer is 32. Let's do that same thing here. Keep, change, and flip. And I think I might even show you why this is the answer. But let's just get the answer first. Let's keep 7/12. Let's change division into multiplication and flip to the reciprocal. And then we just multiply straight across. 28/12. How many 12s are in 28? 2. 2 wholes, because 12 times 2 is 24. That means we would have 4 12s left, dot, 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 and that is 2 1/3. Let me show you in a picture. I guess this is less of a speed run, but I just love doing this. It's just fun. I do this with some kids in my advisory. So I'm going to draw like this. 12s. Sure. Okay, here I have 7. Oh, can I like do a straight line? Oh, that's cool. Okay. 1, 2, 3. Boom. Right, let's just go. Here I have 6 12s. Here I have 7 12s. And I want to know how many 1/4s are in 7 12s. Well, look, here we have like the rows. There's 1, 2, 3, 4 columns. And this column would be 1/4. Oh, 1/4, 2/4, 3/4, 4/4. How many 1/4s are there in this? Well, here's 1 1/4. Here's another fourth. Do I have a fourth here? No, I have part of a fourth. How much of this fourth is there? 1/3 of a fourth. So that was 2 1/3. Of the total, this is 1/12, but 1/12 is a third of a fourth. What? Yeah, crazy. Another way you could have, never mind, we're just going to keep, change, flip, and I'll show you an interesting thing of that's what the picture looks like. Moving on, moving on, moving on. Okay. Boom, 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 boom. Bang. All right. This one, come on, y'all. We've been subtracting for a few years now. If we estimate, it's going to be about 35, less than 35 though. Okay, the reason I threw this extra one in here is to remember there's something already there. So can I do 1 minus 8? No, no, no. So we're going to go here. I can't regroup. I have to go here. I can't regroup. Need to change this 4 to be a 3. Then I would have 10 ones, which will become 9 actually. And this would become 10. But I actually need to give some here. And I already have 1 in the hundredths place. Plus 10 more would make 11 hundredths. 11 minus 8 is 3. 9 minus 7 is 2. 9 minus 5 is 4. And then we have 3 left. Okay, 2 last problems. Mr. Dick says you should estimate first. So let's just say this is like 60 times 3. I rounded both of them up, so I know my answer is going to be less than 180. Yeah. And if it was just times 2, that would be like 120. So it's going to be maybe between 120 and 180. Can you guys hear this like ice cream truck outside? Hopefully not. It's kind of annoying, but whatever. And then I'm going to estimate this one to be kind of like 30 divided by 2 or 30 divided by 3. I know that one would be 15. This one would be 10. It's going to be somewhere between these two. That's just a quick estimate. All right. I'm going to multiply 57 and 400ths. And I'm just going to write times 2.7. I'm not worrying about lining up the digits. If I put an extra 0 here, then you guys would just put a bunch of zeros. We don't need to do that. Let's just keep it as is. Oh my gosh, it's getting really loud. I'm so annoyed. Okay, 28. All right, 7 times 0 is nothing. Plus the 2 is 2. 7 times 7, 49. 7 times 5, 35. Plus 4 is 39. Okay, now my friends, this 2 is in a bigger place value. So we need to put a 0 as a placeholder to increase. It's different. What's more, this 2 or the 7? The 2 is. It's 2 wholes. This is 7/10. So you need to put that 0 when you multiply. Any number. Like any 2-digit, 3-digit number, you need to keep increasing the place value. All right, so then this is 8, 0, 14, 10, 11. We add it up. 8, boom, 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 boom. Don't forget to regroup this one. Some of you forgot that. Okay, and we estimated it should be about between 120 to 180. Well, then my decimal place must go here. 154 and 8 thousandths. All right, cool. A cool thing that someone did, we can change this one. Basically what I would suggest is like, let's just make it not be a decimal. Emmanuel actually doubled both numbers to have it like 66.28 divided by 5. So he didn't have a decimal that way. That was cool too. But what I'm going to do, I'm just going to multiply both times 10, the dividend and the divisor, and it will still give me the same answer. Because how many 2s are in 30, 15? How many 25s are in 300? Same thing, right? About 15, 12. So let's just get to the division. Bang. And if you wanted to just keep it, that's fine. Like if you kept it in there, the decimal point, that's also fine too. Just make sure you estimate to know where that decimal place will go. All right, how many 25s are in 33? 1. This 1 goes here. It's not, there's 125 in 3. There's 125 in 33. Let's subtract. What's 33 minus 25? 8. We bring down the 1. How many 25s are in 81? 3. Because think money. 3 times 25 is 75. Subtract, I know it's 6. Did you? Yeah, I could do this, but I kind of just know. Now I bring down this 4. How many 25s are in 64? 2, because that's 50. And I subtract, I have 14 left. Am I done when I divide decimals? No. We can put some more zeros here. I would go all the way to the thousandths place. Thousandth. Bang, let's bring down that big old 0. How many 25s are in 140? 5. 5 quarters is the same as 125. We subtract. We have 15 this time. We bring it down. How many 25s are in 150? It is 6. So I would love for you to go back on a separate sheet of paper and do this along with me. If you already were, great. But you want to fix this. Watch this again. Watch the part that's confusing. Ask me the thing you need more practice of, because we have another quiz on computations each week until the end of the school year on paper or on quizzes. So let's remember what to do when we add, subtract, multiply, and divide fractions and decimals. Good job. Hope that was helpful.